Hey class, so today we're going to go over domain restrictions. These would be domain restrictions for real valued functions. Now there are going to be two types of restrictions for the domain of real valued functions that we're going to be going over that you will need to know for this class. So the first one, we've talked about this at some length here and there. You cannot divide by, that's right, you guessed it, 0. You cannot divide by 0. So in other words, the denominator, it'll cause the denominator to not exist, right? You cannot divide by 0. So let's look at this example. Let's find the domain of the function x plus x over 2x plus 3. Note that this x all by itself imposes no new domain restrictions, neither does this x up top. But what does create a domain restriction is this 2x plus 3 in the bottom. That 2x plus 3 in the bottom cannot equal 0. Because if that 2x plus 3 in the bottom equals 0, that means we are dividing by 0, and we cannot have that. So we solve this inequality, right, because they're not equal to each other, for x, and we'll find that x cannot be negative 3 halves. So that means any number in the number line is good except for negative 3 halves. So our domain would simply be from negative infinity to negative 3 halves union negative 3 halves to infinity. And this should feel very similar to what we were doing with inequalities in the previous lesson. Now there is one other that you should be aware of. You cannot take the square root of a negative number and have a real valued function. Right? Because if you take the square root of a negative number, you'll end up with an imaginary number. And we're interested in real valued functions. And so this ARG that you see here, that stands for argument. So, and the argument is just what goes inside the square root. And so the argument has to be equal to or greater than 0, right? The argument cannot be less than 0. So let's look at our example function here. We have x squared plus 3 multiplied by the square root of a statement. X squared plus 3 has no effect on the domain. So the only thing that does is what's inside the square root, right? The argument. And so x minus 5 must be equal to or greater than 0. So we solve this inequality to be x equal to or greater than positive 5. And note, if you plug in positive 5, you get 0. Anything more than 5, you're taking the square root of a positive number. That's what we want. And so we would say our domain is simply 5 all the way on up until infinity. And that would be our domain for that example. Moving forward, we've got some more examples now. And so now we've got a couple of things going on. One, x plus 2. And we've got x minus 5. And so you can see that x plus 2 cannot be 0. And same is true for x minus 5. X minus 5 cannot be 0. Solve both of these for x. And we find that x cannot be -2, x cannot be 5. But everything else is allowed. And if you look at this on a number line, like we were doing in the previous section, it would look like this. And all of those values would be our domain. So our domain is -infinity to -2, union -2 to 5, union 5 onto infinity. And that is our domain for that particular function. Next, again, we've got two different things. Note the 3, the x plus 5, have no effect on the domain. But what does have an effect is x minus 5 and the argument right here, right? So x minus 5 cannot be 0. And 10 minus x must be equal to or greater than 0, right? Because 10 minus x is what's inside the square root. And so once again, we see that x cannot be positive 5. And over here, we've got negative x is equal to or greater than -10. And then multiply both sides by -1 to find that x must be equal to or less than positive 10. So putting these together, we've got 10, we got 5 here. And we go to the left, but we can't be 5. We go on like this, right? X is less than 10, but it cannot be 5. And so our domain is simply -infinity to 5, parentheses, union, parentheses, 5, all the way up to 10. And the 10 we include with a bracket. And that is our domain for that function. Next example. Again, note that x squared plus 5 does not affect the domain, but this expression in the bottom does. So first thing we note that x plus 3, or should I say the square root of x plus 3, cannot be 0, which would imply, right, you square both sides, that x cannot equal -3. Easy enough. But also note that x plus 3 is an argument for the square root. So x plus 3 must be equal to or greater than 0. And we solve that for x, and we find that x must be equal to or greater than -3. Put these two together, and note that this does not equal, knocks out this equal sign here, and so we see that x has to be greater than -3 for this to work. And so our domain becomes -3 parentheses up to infinity. And that is our domain for that function. All right, so note that all these terms here have no effect on the domain. X, even though it's being multiplied by a square root, doesn't affect the domain. The only thing that affects the domain is what is inside that square root. So you see we've got -x plus 2 times x minus 3 must be equal to or greater than 0. We got this negative hanging out. Multiply both sides by the negative sign. And we'll see that x plus 2 times x minus 3 must be equal to or less than 0. And now we're going to solve this inequality. Note from a few lessons before, actually just one lesson before, I should say, -2, +3 solve the inequality. Like so. And now we're going to use the method of test points. So you plug that -3 into here. -3 plus 2 is -1. -3 minus 3 is -6. And here we find out, is that equal to or less than 0? And indeed, 6 is not equal to or less than 0, so false. And then we pick a point in between here and here. So we pick 0. Giving us -6. And that is, in fact, true. So we would include that. And now we come over here. At x equals 4. All right, so next point. 4 plus 2 is 6. 4 minus 3 is 1. And here we see that 6 is in fact not equal to or less than 0. That is a false statement. And so our domain, based on what we have here, is simply -2 to +3. All right, so -2 to 3 is the only values of x where we would have a real output for this function. Last example. Again, the 5 has no impact on what's going on, only what's inside the square root does. And so we've got a few things going on here. So x equals 2 solves things, and x equals -3/2 solves things. Right, because if I plug in -3/2, I get 0. If I plug in +2, I get 0. And 0 is equal to or greater than itself. So we put filled in circle here, filled in circle here. And now we do the method of test points. -3/2, it's -1.5. So let's start off at -2. So -2 minus 2, that's -4. Okay. Plug -2 into here. And we have -4 plus 3 equal to or greater than 0. We'll find out if that's true. So we got +16 multiplied by -1. And -16 is, in fact, not greater than 0. And so we would say that is false. and we don't include it. Next, we pick a point in between negative 1.5 and 2. And so we would pick an easy number. I'll pick an easy number. You can pick a harder number if you want, but I'm going to pick an easy number, 0. And so we've got negative 2 squared multiplied by 3. And so negative 2 squared is 4. 4 times 3 is 12. And so we've got 12 equal to or greater than 0. This is true. 12 is, in fact, equal to or greater than 0. Now we pick the next point after 2. I'm going to pick 3. Three minus 2 is 1, so I got 1 squared. And then I've got 2 times 3, which is 6, plus 3, equal to or greater than 0. So 1 squared is 1, 6 plus 3 is 9. 9 is, in fact, greater than 0. So that is a true statement. So this was true, and then that was true. There is no need to break this up at 2, so we would say the domain is simply negative 3/2 up to infinity. And that is our domain for that function.